Okay, so placebos would not be used in an observational study. We only use placebos in experiments as part of the blinding process because we don't want people to know which treatment they are receiving. As far as observational studies go, people choose their own treatments, so there's really no sense in having a placebo going. Okay. All right. Let's try. We'll try another one, and then I've got 2 questions related to the content I'm teaching today. Okay. So this is, I think, question 2. All right. So yeah, right now all of these basic questions are just yes or no's, I guess. All right. So the mean weight. Oh, you can read this. I'll give you guys a minute to figure this out. Okay, 10 seconds, just click something now. All right, you guys got it? Okay, here we are. Okay, let's see. Does it show the result? How does this go? Okay. All right, and then indeed that is the correct answer. Okay, because so 472 would be 122 pounds over the mean. Okay, 122 pounds would be over 3 standard deviations away from the mean. So that is definitely unusual. And we would just say, in general, anything over 2 standard deviations can be considered unusual. Anything over 3 standard deviations would be highly unusual. Okay. So there we go. Okay. Cool. You guys have a quiz tomorrow in section. So I will get those distributed or sent to your TAs, and they'll administer the quiz. So make sure you arrive to your section on time, because it'll be right at the beginning. It'll be half an hour. If you guys arrive late, you'll be out of luck. So make sure you arrive to section on time. Okay. All right, so today we are going to begin Chapter 4. Again, tomorrow's quiz will be Chapter 1 through 3 only, okay? All right, so let's enter Chapter 4. Chapter 4 is on correlation and linear regression. Today I think we'll just manage to get through the correlation portion of the topic. All right, so what this is, the big picture here, okay, is that we can describe the relationship between 2 numeric variables. Okay? And so it's very important that both of the variables are numeric. If one of them is categorical, this stuff will not work. Okay? Okay, and so our basic tool would be a scatterplot. Okay, so basic tool the scatter plot, okay? And so, you know, what we could do is, let's say our data comes from all the 50 states, okay? So we're going to have a row for each state. Okay, and then we're going to gather two numeric variables, okay? And these numeric variables will be the median age of marriage. So, you know, people get married, right? Sometimes, right? Okay. So, and this will just be just for the purpose of this illustration, it'll just be a male-female marriage. Okay. This is going to be the median age of marriage for men, and then this will be the median age of marriage for women. Well, actually, it really doesn't even, well, yeah, it doesn't even matter. Okay, it doesn't even have, this can be, this can include same-sex marriage. It's just, you know, you get, so, you know, for the state, let's say we go to, we're just going to list them off. So we go Alabama, what is it, Alaska, Arizona, Arkansas. Yeah, okay, we're not going to go through. All right, someone went to, paid attention in 5th grade, right? Okay, so anyway, you know, let's say within 1 year, okay, in 2013 or 2014, 2015, whatever, in a certain year, let's say a whole bunch of people got married, okay? A bunch of people got married, and all we're going to do is just look at all of the marriages that were filed, and we're going to pick out the median age for the men and the median age for the women. So it doesn't even matter what, you know, maybe there were, you know, maybe more men got married than women or whatever, who knows, okay? We just look at the median age of marriage for men in Alabama, and I don't know, I'm making up a number here, let's say it's 24, okay? That's probably too low. All right, 20, we'll say 25, and then median age of marriage for women in Alabama, we'll say 23, okay? I'm just making up these numbers. Don't come back and say, Alabama was this, okay? And then we go to Alaska. I think it's abbreviated AK. I don't know. Who knows? People in Alaska, maybe 29 and 26.5 or something like that, okay? We're just, so all we're doing is we're just summarizing all of the marriages that were filed. Okay, and I'm again just making up numbers here. Okay, and then we're just going to graph these. Okay, so here will be median age of marriage for men. Okay, and this side we're just going to write M age marriage for women, okay? And we're just, you know, we just graph these. So, you know, let's say 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, so I'm just going to, and then 1, 2, 3, 4, 5, 6, 7. Okay, so we'll say, okay. All right, and then so Alabama gets a dot at 25, 23 right there. This would be Alabama. And then Alaska gets a dot at 29, 26 and a half. So I'm just kind of eyeballing this right there. And Arizona at 27 and at 25. A dot right there, okay? All right, and if I completed the rest of the table all the way down to what, Wyoming, and I plotted all of these, how many dots will I end up here? What's that? I will have 50 dots, 50 nifty United States. Okay, something like this, right? And so, I don't know. Okay, we're just going to pretend that there's 50 dots there. And so overall, we can describe, you know, this, sorry. So this is dot, dot, dot. Okay, so we have 50 rows. So here we'll have 50 dots, one for each state. Okay, and so we can describe the relationship between men and women. Okay, and so, you know, our general trend will be something like states where the median age of marriage for men is high tend to have high median age of marriage for women. Okay. Tend to have high, you know, median age of marriage for women. Okay, and then, you know, vice versa, states where median age of marriage is low tend to have low median age of marriage for women. Okay, so high goes with high and low goes with low. Okay, and then on Friday we will extend this further to say, you know, we will create some kind of trend line, and we would have an equation to describe the trend line. Okay, all right, and this is called the regression line. And a regression line, in plain English, would be something like the median age of marriage for women is about 2 years less than the median age of marriage for men. Something like that, okay? Just making up something like that, okay? And so, you know, eventually we'll get to a regression, and where we characterize the line, okay? Describe the trend line. Okay, but we'll worry about the regression trend line later. Today we're just going to focus on kind of describing this topic of correlation. All right, so far so good? Okay, so when describing a relationship, between x, or I say between two numeric variables, okay, we should talk, should mention, there are pretty much, there's three things: direction, or I guess trend, or direction, strength, and shape. Okay? So this first idea is trend and direction, okay? Trend slash direction, okay? So a relationship can either have a positive trend, or it can have a negative trend, or neither, okay? So a relationship will have positive trend, negative trend, or neither. Okay, so let's talk about this. So positive trend means that I hope everyone's healthy. Large X is associated with large Y in general, okay? And small x is associated with small y. Okay, again, in general. Okay, or in other words, we can say you know, x and y tend to move in the same direction. Okay, so here we have x, we have y, and so what we can have is you know, age of vehicle in years, and mileage on vehicle in miles. Okay, and so you know, you have an old car with lots of miles, high X, high Y. Okay, new car with very few miles, low X, low Y. Okay, and you're going to have data points in between. And of course, you know, you might have a new car with lots of miles or an old car with very few miles, but in general, we have a positive relationship, positive trend, where large X is associated with large Y. Okay, so that's just an example here. So if we were to just pick out different vehicles, look at different vehicles on, you know, some car lot, not at a dealership, but like, I guess, a parking lot. Okay, you know, go down the parking lot at a store. Generally, newer vehicles will have less mileage on it. Older vehicles will have more. Or you can go down, whatever, Craigslist, see what cars are for sale, and we'll see that kind of trend. Oh, shoot, I'm saving these as the wrong thing. Okay. All right. On the other hand, we have negative trend. Okay. And in this case, it's just the opposite. Large X goes with small y, and small x goes with large y, of course, in general. All right, and so you know, here we could look at a bunch of different countries. Okay, so you know, one line per country. Instead of, you know, on the previous slide we had one line per state. Here, you know, one line per country, so one dot per country, and this is a little interesting, but we'll have literacy rate. Okay, so you know, you look at countries with high literacy, low literacy. Okay, and over here we're going to have births per woman. Okay, and what you will see, you know, we have a lot of countries in this sector over here. Okay, with high literacy and not very many births, but overall, if we plotted this, we would see an overall kind of negative trend like this, where countries where there is low literacy, for whatever reason, the women have more children, okay? So, so here, the general trend is negative, and that means, in general, countries with high literacy have fewer births per woman. Okay, and countries with low literacy have many births per woman. Okay. So we will we'll talk about this, but this is an important. I think it's clear, but it's important to say correlation or a relationship. Correlation is not causation. Okay, so if you're you cannot say when a woman learns how to read, she doesn't want children anymore. It doesn't work that way. Okay, you cannot say if you increase the literacy in the country, that is going to decrease the number of births per woman. Things like literacy is complicated, right? Like there are lots of factors that go into what determines the literacy rate. We're very fortunate to live in the United States where there is high literacy. We have access to education is quite available to everyone, but not so in all parts of the world. And so dramatic improvements have been made. So almost very many of the countries are here, and not very many countries are over here. But things are complicated, and things that determine births per woman, there are many things. It could be argued that making the changes to your country that will lead to higher literacy will also somehow affect births per woman. You might be able to argue that, but to say literacy directly affects births per woman, that would be a bit nonsensical to try to make that claim. Okay, and these graphs and scatter plots are not intended for anything like that. It's just to say, hey, we're seeing this interesting relationship between these two numeric variables. Okay, so that is positive trend, negative trend. And then sometimes we have situations where we have neither positive nor negative. Okay, and so here we could look at someone's shoe size. Okay, so we'll say, looking at adults in the U.S. Okay, we'll look at their shoe size, and we'll look at their IQ score. Okay, and what we will see is we will see people with large shoe sizes with low IQs, large shoe sizes with average IQs, large shoe sizes with high IQs, people with small shoe sizes across the board, and you're just going to see kind of points all over the place, okay? And so here, you don't really have any kind of trend, and you're going to probably have more people in this middle-ish shoe size range, okay? So lots and lots of, so this, the points will have a greater density in the middle where more people are average shoe size and average IQ. But overall, you got no real relationship, okay? So, when looking at adults, okay, large shoes can be associated with high or low IQ, and same with small shoes. Small shoes can be associated with high or low IQ. Okay? So we have that. Okay? You can also have, and I'll just go ahead and throw this on the same slide here. You can have a relationship that looks like this. Okay? So here there is, so over here, it's neither positive nor negative, and here we would just say, you know, no real association, okay? Over here, there's definitely an association, okay? Association exists. So this could be time, and then this could be altitude of, I don't know, you know, toy rocket. Okay, so you know, you could launch a toy rocket or something. So as time goes on, it goes up, and then it comes back down, right? And we can plot this. Okay, so here there's definitely some kind of association, but using a word like positive or negative will not describe the overall relationship. Okay, so positive or negative is not sufficient as a descriptor. Okay, so that is, so here we have an example where association does exist, but you can't say positive nor negative. Okay, over here you can't say positive nor negative because there's just no real association. Is that okay? All right, let's try a couple clicker questions here. All right, so here we go. So we're gonna just look at, I guess this data will come from, I don't know, over the course of a year, okay? So maybe I should include that. Data comes from a year's worth of sales data. Okay, so X is the outside temperature, and Y will be the number of sweaters sold. We would expect the correlation, so you know, looking at each day. Oh, I'm sorry, I gotta turn on the device here. Sorry. Okay, here we go. Okay. All right, everybody's clicking away here. Look at that. Probably don't need to give you a full minute. We'll give you 30 seconds to get your answers in for this one. So is high outside temperature associated? I don't know. Okay. All right, is that everybody? 135? 136, get your clicks in. Last call for clicks. Just click something, A, B, or C. All right, here we go. 139, okay. So we'll end the clock there. And, dun dun dun. And the answer is indeed negative, okay? So the idea here is if you think of, I don't know, just at the store, right? You're going shopping for clothes. If it's hot outside, you are less likely to purchase sweaters that day, okay? So looking across the year, you know, days that are cold, winter season, stores more likely to sell more, what am I talking about? More sweaters when it's cold out, more sweaters when it's hot out, so high temperature. So high X will be associated with low Y, small x will be associated with large Y. Okay, so we've got a negative trend there. Okay, I've got one more here, okay. All right. Clicker question 4. All right, so we're gathering a random representative sample of the USA. Okay, X is going to be a person's height, and Y is the person's reading ability. Okay, we would expect the correlation to be so we're getting a representative sample of the USA. Okay, 130, so I got 139. Where are my last two straggling clickers? All right, time running out. Okay, well, I don't know what happened here. All right, we're gonna hit stop. There we go, and, oh, okay. Well, the answer is A. What? Oh, everyone's angry now. Okay. All right, so we're gathering a random representative sample in the United States, okay? So you have to think, what does the USA look like, okay? We got everybody, we have children. You have forgotten about the children, okay? And that's gonna, that will create an overall positive relationship, okay? Huh? So you're right. Listen up, okay? You know, once you reach adulthood, it's true. We will not expect to see correlation between height and reading ability, okay? So these would be, this would be, you know, adults and things like that. But think of children, right? And you're gonna see definitely a positive relationship, okay? Little kids, right? If you have a little short kid, they're probably young, they're probably in 1st grade, their reading ability is going to be of that of a 1st grader, okay? And as kids continue to grow and get older, their reading ability will improve, and so you will see definitely a positive trend, okay? So there is a positive trend. You're right, if I had said only adults, we would probably see no relationship. Yeah? You're right. But listen up. So I'm okay. So the vast majority, okay, in terms of you know, people, minors, okay, minors probably consist maybe 25 to 30% of the population, okay. No, you will have a correlation. I promise you. I'm not. Just say you tricked us. I'm not trying to be mean, okay? All right, but you have to think of what the population looks like, okay? So it was a tricky question, right? I apologize that it was a tricky question, but there's definitely a positive correlation. There definitely is a positive correlation. You guys are all gonna hate me now, okay? So even if this is super heavy, okay, the fact that these points exist out here is going to create the trend, okay? Just like where did shoot? Hang on, okay, I got to just create a new slide now. Okay, so just like over here, if we looked at the data, the bulk of the data is going to be here, okay? Many countries in the world are modernized, okay? Even countries that used to be considered third world countries, you know, 30 years ago today are no longer third world countries. And so you really only have a few countries out here, but that's still enough to create the overall negative trend, okay? So that exists. Okay. All right. I'll try not to make such controversial questions in the future. All right. I'll just make them hard and not so tricky. I don't know. Well, I think it's sometimes. I think tricky questions are good learning points, and when it comes to like clicker stuff where it like your score only makes just the itsy bitsyest difference, I think that's a good time to throw in tricky questions rather than on higher stakes times. Okay. I do think there's some merit in having a tricky question. Okay. So we talked about direction. We'll talk about strength now. Strength of a relationship. Okay. And so, with strong, this would describe little scatter. Okay. Little scatter, and you can make good predictions of y based on x. Okay. And over here, a weak relationship will show lots of scatter. Okay. And, your predictions of y based on x are less precise. Okay, and so a strong relationship would look something like this. And whereas a weaker relationship would, and these are just kind of exaggerated pictures here, will look something like this. So overall still positive. So this is positive trend, and this also has positive trend. But this we would say strong association and weaker association. Okay, so things that are very predictable, we can have strong or weak association. So some examples, okay, is we could take someone's height and use their height to try to predict their weight, y, okay? And yes, overall, we would see a positive, bless you, overall a positive relationship between x and y. In general, taller people weigh more. In general, shorter people weigh less, okay? But there's still quite a bit of variation. A better, or what will give a stronger relationship, is if x is waist size and y is weight. Okay? And in general, just very, very strongly this relationship, meaning people with very large waists weigh more, people with small waists weigh less. And that relationship is a much stronger way to make predictions for weight. Okay, of course, it would be rude to ask someone's weight. It would be rude to ask someone's waist size. So, I guess I don't know if it's polite or rude to ask someone's height. It's kind of a gray thing. It's like only if they are. I don't know. Okay. But so anyway, we've got strong association and weaker association, okay? And it can apply to positive or negative relationships, okay? And lastly, we have the shape of a relationship, okay? And for this class, we will only consider linear or nonlinear. Now you can take an entire course devoted to the topic of regression, okay? But what linear means is that the trend overall, whether there's lots of spread or not, overall a straight line can kind of describe the relationship between x and y. So here we've got, so here this is positive, strong, and here this is negative and weaker. But these are linear relationships, and linear means a straight line can summarize the overall trend or overall shape. Okay? With nonlinear, this is anything that doesn't fit a straight line. So stuff that looks like that, stuff that looks like this. Okay? So anything that's not a straight line, you would say nonlinear. Okay? Now, if you took an advanced statistics course or a course devoted to regression only, then you might further break these down into things like quadratic or exponential or sinusoidal, whatever you want to say. But as far as this class goes, we're only going to worry about whether it's linear or nonlinear. Okay? Maybe just one more slide here. I know you guys are itching to get out of here. One more slide, and that is the numeric summary. Okay, so and I'll cover this in further detail on Friday. So for linear relationships only, okay. So for linear relationships, okay, we can use R, which is the correlation coefficient, or just correlation for short, as a numeric summary that describes the direction and strength of a relationship. Okay? So R can take on values between -1 and 1, okay? And I'll repeat these on Friday, but the sign of R is the sign or the direction of the relationship. Okay, and if R is close to 0, the relationship is weak. And if R is far from 0, the relationship is strong. Okay, we'll stop there, and I'll post up a few exercises for you guys to try out. You guys have a quiz tomorrow in your section, so be sure you get to section on time.